I am Danezis. I'm the chief scientist of Mysten Labs. I'm part of the team that actually built Walrus. In fact, this is my first Basecamp. Last year, I missed it because before Sui was 1 year old, we were actually already building Walrus, and I was busy doing that instead of coming to Basecamp. So it is my first Basecamp. I'm very glad to be here. Now, what is the problem we're trying to solve with Walrus, and what is the problem we're trying to solve full stop? Let's talk about that. We're all used to this experience from Web 2. You love an article, you love some media, you try to go back to it a moment later, and it is not there anymore. Frustrating, and there is nothing you can do about it. Now, sadly, despite the fact that Web3 promises higher availability, higher security, let's say, we only have provided this so far for just transactions, right, on a blockchain, for just an accounting layer. But the world is not built on accounting layers, the world is built on computing infrastructures. And in particular, the world is built on computing infrastructures that, first of all, store stuff and ensure that it's there the next day. And even today, the Web3 ecosystem has not managed to deliver this. So very often we see NFT collections that are meant to represent real digital assets with value that at the end of the day store those assets on traditional Web2 infrastructures, and these assets just disappear when someone forgets to pay their bill or when the service provider just offboards basically whoever basically uploaded the collection. Even worse, sometimes you look and you try to use a decentralized application, a dApp, and you go back to the front end and it's not there anymore. So you can't actually use this permissionless, always available blockchain application because literally the website on which the UI should be available is just not there anymore. So we cannot really say that we can have an on-chain future for the full stack, right? Without also having usable on-chain data and storage. And this is really the challenge we set off to tackle by building Walrus, okay? And Walrus, what is Walrus? And I'm really proud to start by saying Walrus is a protocol running on Sui. Right? Walrus is a protocol running on Sui that offers secure, decentralized storage. So we're at this part of the journey where Mysten Labs is not just building an infrastructure Sui, but Mysten Labs is actually using that infrastructure to build more and more infrastructure like everybody else in this room. And what is the vision of Walrus? The vision of Walrus is not just to allow you to do basic things like store some resources, store some images, store some videos, store a website, and be able to read it again. Of course, it allows you to do that, okay? And it allows you to do that with very high assurance that the website will be there and that the website or the images or the videos will be actually what you uploaded. But at a high level, Walrus also allows you to program that experience around managing data. So Walrus is really storage for grown-ups that really consider that storage is an integral part of their application that needs to actually manage the resources, manage the cost, manage the life cycle of whatever is being stored, and uses that life cycle as part of the logic of their decentralized application. And because Walrus is a protocol on Sui, it is tightly integrated with the Sui programming experience. So we can do things like, having now a ticket, and the ticket has both some metadata that is stored on Sui, like for example the times and who owns it and what kind of access it gives to a particular venue, but it can also have associated media with it, right? That is stored on Walrus, and the two can work together. You can transfer them together, you can unveil some while keeping other private, you can actually program with both of these things together because Walrus is a protocol on Sui. Now, let's talk a little bit about how Walrus achieves the properties it achieves of, secure, decentralized storage. First of all, in order to make Walrus possible, we had to really rethink and reinvent how decentralized storage works. Traditional decentralized storage, and there are protocols that have been proposed before, really takes a file, broadly speaking, and stores it everywhere. Now, the problem with that is that this is very expensive, right? If I want to make sure that that file doesn't disappear, I cannot store it in 1, 2, 3, 4, 5 places because they may just disappear, right? I have to store it in hundreds of places, which means that to store something, I have to spend hundreds of times the storage in the network that I need to store. Walrus solves this problem, right? It uses erasure coding to take a file, erasure code it, and then just distribute little chunks of that erasure coded file. And that means that no matter in how many places the file is stored, it just takes a constant overhead in the network of about 5 times the size of the original file, right? I can store it on 100 nodes, I can store it on 1,000. This doesn't change. It's just 5 times more expensive, okay? Now, at the same time, even though the cost, if you want, the blow up in cost is limited, the actual resilience that I get is quite extreme. Any 1 to 2/3 of the places where these little chunks of the file are stored can just disappear, and the protocol will keep functioning. 2/3 of the network can disappear and you can still read files, about 1/3 of the network can disappear and you will still be able to write files to the network. And furthermore, our encoding scheme ensures that as nodes in Walrus become unreliable or fail, or operators decide to just close shop and move on, the protocol heals itself. New operators can on board take on the responsibilities of operators that have left, and the economics and the protocol just works. Walrus is also fundamentally different from traditional L1 that do transaction processing, in that the more nodes you add to the network, the more storage capacity you add, right? So Walrus is, in that sense, infinitely scalable, in that if you add more machines, more storage nodes, more hard disks, the capacity will grow as the need for storage and decentralized storage grows. Because Walrus uses Sui, it is integrated in the Sui smart contract platform. All of its economics, its tokenomics, its governance around storage nodes, staking, delegation of stake, rewards around staking, all of that is smart contracts on Sui. And what does that mean? It means, first of all, that you can just use all of these resources and assets in Sui DeFi and in other Sui experiences that you're used to, therefore contributing, if you want, to the wealth of the ecosystem. It also means that because all of these command functions of the storage are smart contracts, you can write your own smart contracts that actually drive how Walrus operates and customize how Walrus operates. So it's an application platform as well as a storage network in that sense. And in fact, we actually initiated Walrus and shipped it with one key application that illustrates how you can use smart contracts in order to build more experiences on Walrus, called Walrus Sites. This is the product that allows you to upload a whole website and serve it through Walrus to normal users just with a web browser, with no drama, while actually your website backend or front end of the application is in a decentralized store. Now, Walrus is live. This is very important, right? So we basically delivered from vision, let's say, before Basecamp last year to a mainnet in about a year. It's been live for about 5 weeks. I made that slide maybe 2 days ago, so the numbers are a little bit older. And it has already stored 440 terabytes of encoded data. So this is quite significant. This is a little bit more than 10% of the current network capacity, but it is also very important to realize that as that utilization goes up, storage providers have all the incentives in the world to add more capacity. So you should not see that as a cap. You should just see that as the current capacity that, of course, will increase to meet demand as infrastructure should do. About 5 million blobs have been stored. These are the 447 terabytes. And interestingly, about 500,000 WAL has been spent in storage operations. So WAL is not just this speculative asset, it's not just a token, right? It is actually used to store stuff in the network. But of course, about 1 billion WAL has also been used in order to stake with storage nodes that determine who the committee of storage nodes are, which is also a very important operation to ensure that the entities that manage that system, that actually operate the decentralized network, are trustworthy and have the support of the community. And we have observed peak upload volumes of around 80 or more megabytes a second. This far exceeds even the plans of other storage networks in the decentralization space. Now, these are nice numbers, but let's talk a little bit about specific use cases that partners are using Walrus for. First of all, we are very proud to be working with Tusky. That is offering a cloud store, a little bit like Google Drive or Dropbox, etc., using Walrus as a storage network underneath. They're doing their own encryption. They basically allow you to go there using ZK login, open an account, and then store your files, share them with people, etc. So the experience is seamless. It feels as if you're not using Web3, which is great, and yet you get all the properties of Web3 in terms of security, which is exactly what we want. We want to make sure that people can use Web3 without any of the friction and yet all of the benefits. We're also very happy to be working with 3DOS. 3DOS is a partner that is building a decentralized network for manufacturing, my words. They connect folks with 3D printers, with folks who have a need to print 3D stuff and have it shipped to them, and they basically coordinate that through Sui and store assets such as 3D designs, as well as specifications and everything else on Walrus. So this is a great example where Walrus and Sui work together as a platform. On one side, you coordinate, at this point, manufacturing activity on Sui, and all of the big files that you need as part of that activity are stored on Walrus. We're also very proud to be working with Linera. Linera is an L1 that allows you to spin up microchains. You can have your own little little blockchain effectively that does a few things between you and other business partners you have, and they support both reading from Walrus today as well as in the future writing to Walrus and interacting with Sui in order to prove that particular Walrus blobs have specific properties, which could be very useful if you want, for example, to store log data or certify what kind of data is actually stored on Walrus. Talus is also an L1 that provides agentic AI. They allow you to define agents and to do effectively and drive basically AI tasks in the blockchain. They will use Walrus as well for storing both inferences and logs of activity. One Championship uses Walrus for doing user engagement. They have a nice comic book that you can access if you're one of their customers on Walrus. And finally, we also announced Klenosaurus that is providing a great set of collectibles and storytelling that will be storing data on Walrus as well. Now, let me talk a little bit about the future. Walrus provides decentralized publishing, right? So all the data you put on Walrus by default is public, okay? And this is where we start. If you want, a blockchain is a public record of transactions. A decentralized store in the blockchain space is a public record of resources that are stored. But let's be clear about our belief. Privacy is a right for individuals, and confidentiality is a business enabler for enterprises, okay? So it is not possible to imagine that Web3 technologies will really substitute a lot of the activity that we see being done in Web2, while everything that happens is entirely transparent. This is just not possible. Most businesses do not want that. Most individuals do not want that. So it is time for us and our ecosystem to start supporting confidentiality. And Seal is, to some extent, our first product that does that. What is Seal? Seal allows you to generate and store effectively encryption keys in a Web3 manner on key servers. And then it allows you, as a developer, to define policies about who has the right to access these keys and under what circumstances. And these policies are defined as Sui smart contracts. And this is very important, that there are Sui smart contracts. So suddenly your programming experience around defining who has the right to access particular resources is writing smart contracts as you would do for your transaction processing needs. What can you do with Seal? You can do some, table stakes things, such as upload some private files, share them with your business partners, with your friends, etc. This is amazing, and you have entire flexibility on how to define that. You can basically share them by other people by address or by NFT or anything like that. Because Seal is integrated into the smart contract platform, you can also create paid-for experiences. You can say, well, I'm uploading some encrypted media content, for example, and it is only the folks that pay or subscribe, for example, to that content that can actually get access to it. And you can start combining the flexibility of doing access control on Sui and the confidentiality that Seal provides for Walrus resources to build more and more complex social experiences that integrate privacy. You can think about defining who your friends are and add friends and remove friends and only give access to, let's say, your feed of updates in a social context to the people who are your friends. You will hear much more about Seal on the dev stage. Ben Riva is actually giving a talk for 15 minutes, so this is just a preview. But what is really important is, in the same way that Walrus extends what you can do in the Sui ecosystem to data, Seal extends what you can do in the Sui ecosystem by actually now having programmatic access to secrets and being able to keep secrets or share secrets with the people who are authorized programmatically through the Sui ecosystem. The second thing that I want to talk about that, again, extends what you can do in the Sui Walrus extended kind of ecosystem is Nautilus. Nautilus allows you to use computations that are performed on trusted execution environments and certify that these executions happened correctly, namely the correct program was run on a trusted execution environment on specific data, and that led to a specific output, and then take that output and bring it back to Sui. So now you can write Sui smart contracts that span the move Sui kind of way of doing smart contracts that we're all used and love today. And then other parts of them actually happen on trusted execution environments. And those parts that happen on trusted execution environments can contain secrets, so you can encrypt, decrypt things, you can sign things there, you can actually process PII, and they also don't have to be deterministic. They are not actually just operating in a VM on a blockchain. They can open connections to the internet, read stuff, do transactions, and generally operate across the whole internet on behalf of a smart contract. So that vastly expands the realm of what you can build within the Sui ecosystem. You can build custom oracles, you can build notaries that certify that particular processes on the wider web have happened. You can actually build private transaction processing engines or matching engines or order books on TEs that then settle on Sui. You can basically do all this. Seal and Nautilus are currently on testnet, and Joy tomorrow will talk a little bit more for 15 minutes about Nautilus if you want to hear more details. So what's next? First of all, I want to share with you a little bit of vision about how we go about thinking of the broader Sui platform at this point. Now, let's be clear. If you just wanted to compute and do transactions, you can go buy a computer and do some transactions. It's fast, it's cheap. This is what you can do. If you just want to store stuff, again, you can go buy a computer. It comes with a big hard disk, and you can just store stuff. The reason you come to Web3, the reason you use blockchains, the reason you use decentralized infrastructures is not just to compute and store. It is to do these things with very high assurances. First of all, security assurances. You want to make sure that you will always have that data be available, always the computation will be available. You want very high integrity guarantees. You want to make sure that everything that happens follows rules that cannot be violated by anyone. This is true about transaction processing. This is true about data as well. And now, we also want to extend the realm of these assurances to confidentiality. You want to make sure that the secrets that need to be kept are kept subject to a particular policy no matter what. So it is these assurances around security that really bring out the value in using blockchains. And on top of these assurances, it is fundamentally decentralization as an assurance that you're looking for. Namely, the knowledge that this is a neutral platform, it is a neutral territory, you can safely build your applications, you will never be excluded from it. There is no entity that will be able to extract a rent from you and jack up the prices just as you basically cannot move anywhere else anymore. It is a neutral platform that you can use with certainty to build your business, and your users can use with certainty in the sense that the rules will be applied even if you as a builder want to change them down the line. So this is really our vision, and this is why we're pushing from transaction processing to storage to more and more kind of security primitives that you can use as a developer to make sure that developers have the best security stack to build decentralized applications in the world. That is what we're trying to do. And for Walrus, what does that mean practically? It means building cheaper, faster, and better infrastructure for storage. So we will keep moving the envelope to make it even cheaper and even faster to store data. And also to look at the problem of quality of service when it comes to reads and when it comes to APIs. We want to make sure that when you store something on Walrus, you get high certainty that not only it can be stored, but it can be read really fast if your application needs that. So that's the next step for Walrus. For Seal, we are trying to build a flexible key management system so that the committees that hold the secrets can change, as well as basically as a content provider, you can set that decryption happens on trusted machines that also rate control how much media is used by particular users to support even more complex business models. And for Nautilus, of course, it is the beginning of this product, and we will be supporting more and more trusted execution environments. Currently, we support AWS Nitro, but there are many other execution environments, both for compute, but also for AI training and specialized key management tasks that we're looking at to extend Nautilus to. As I said, the goal is to provide developers the best decentralized security stack to build applications for their customers. Thank you very much. Walrus is on Mainnet. Please use it. Thank you.